And this recording will be available on our website if you want to refer back to anything that we talk about today. You can check that out at tubalabs.com/pd. If you have any questions while I'm talking, please go ahead and leave those in the chat. I'll stop periodically just to see if there's anything I can answer as we go. And before we get started, if you haven't already signed up for a free Tuba Labs account, or if you're a premium user, that's great. But just so that you have an account before we get started, you can head to tubalabs.com and sign up using your email. That way, as we go through, if you want to follow along with any of the lessons that I'm demoing, you're able to do that and able to follow along with the dashboard as we go. So just wanted to start by introducing myself. My name is Colleen McInerney. I am the math education specialist at Tuba. My email is there. I'll share it again before we sign off for the afternoon. If you have any questions related to math implementation with Tuba, you are welcome to reach out to me. I am a former algebra teacher, 8th grade algebra, geometry, and I also taught 3 years of earth and space science. And I've spent a lot of time working with math teachers, both in the classroom as a department head and then also as a new teacher coach, where I worked for 3 years in high need schools to help starting teachers, first year teachers and second year teachers in their journeys, some of the toughest times of your education or your teaching career. And I started with Tuba this past summer as a math education specialist. So again, I handle everything relating to math at Tuba. So if you have any questions on how you can better implement Tuba in your math classroom, I would love to chat with you. And I will share my email again at the end. So I want to start with a little bit about kind of our philosophy at Tuba with sort of what we believe is missing from math education today. And we think that math education relies really heavily on procedure and repetition. And while there's obviously a place for that in the math classroom, I don't think that anyone could argue that procedure and repetition don't have their place and aren't valuable. We think that students are often introduced to math concepts without any real world context, and that this leads to a lot of disengagement and a lot of lack of student confidence and enjoyment in mathematics. And then we see kind of those consequences borne out in student test scores and their persistence in math education past high school. So enjoying, getting excited about, feeling that connection to STEM careers as a result of kind of that lack of real world context, that lack of engagement earlier on in their math careers. And this has consequences. We obviously are all very aware of, how student achievement in math has gone over the last several years. This represents my 8th grade students as well, who took the NAEP test in 2022. So, I empathize with what we've been experiencing in education these last few years. And so our goal at Tuba is really to get students excited about math by way of this real world engagement piece, which we think is really missing from math instruction today. And so we see data literacy as a way to kind of bridge that gap between the instruction that's happening in our math classrooms that is important and valuable, that's very, procedurally driven, and that real world engagement piece that we know students really need in order to not only be excited about and engaged in their learning, but also be real co-constructors of their knowledge based on their lived experiences and being able to relate to, what's happening, what they're doing in math class with what's happening in the real world. And there's, been some research to support our hypothesis around this, that data sets on current and interesting topics can really pique student interest and help drive that cross-curricular understanding so that students can see why they are learning what they're learning in their math classroom. So if we're, for example, today we're going to be talking about fractions, ratios, percents. If we're learning about fractions, ratios, percents, Why is that actually valuable to the real world? How can I apply this to some context that I'm already familiar with? How are people out in the real world actually using this information or these skills that I'm learning in my math class? So we think that data and using real world data brings that authenticity to the math classroom in ways that can sometimes be superficial in other curricula. So we're going to focus today on fractions, ratios, percents, but I wanted to kind of highlight why we're choosing that area to focus on. And I'll just say before we dive in that at Tubo, we are a supplemental curriculum. So we're not aiming to meet every single standard. We're not trying to replace a core curricula or core instruction around fractions, ratios, percents. What we really aim to do is bring that real world context, bring that data literacy context into math instruction so that students are building on what they learned in their core curriculum and having that kind of deeper conceptual understanding as a result of being engaged through those real world experiences. So just wanted to say before we start, we're not necessarily going to talk about, how to teach fractions, ratios, and percents. That's already happening in your core instruction. We're talking about how to bring that real world component, that data component to the teaching of fractions, ratios, percents, and why that can be important for your students. And we're focusing on this topic in particular because fractions, ratios, and percents really, and really we'll start with fractions. Understanding fractions and that part-whole relationship is so crucial to students' understanding of future math concepts. As a former algebra teacher, I can attest to the fact that my students came in often with a very shaky foundation in terms of their understanding of fractions, and that had real implications for their number sense and their ability to manipulate numbers when it came to algebra, when they had to do that in more abstract ways in learning, when they were learning about variables and how to manipulate variables. So research shows us that having that strong foundation in fractions is critical for algebra. And we know algebra is such a big indicator of so many other, student achievement outcomes in their future math careers and even in their, college attendance and persistence rates. So having that foundation in algebra is super important. And many students come into middle grades having struggled with fraction in elementary school. And then as a result, when they have that shaky foundation in fractions, building on that with ratios and percents can be really challenging. So our goal with the lessons that we'll demo from fractions, ratios, and percents today is to, again, provide that real world context for students to be able to make meaningful connections between the concepts that they're learning and hopefully deepen those connections so that as they move on and progress through the middle grades in these concepts, they have that strong understanding to build from. Okay, so I wanted to have this quote here as sort of embodies our philosophy at Tuba, which is that students need meaningful, real world, authentic contexts in order to make sense of the math that they're learning in the classroom. So I'll be quiet for just a moment so that you're able to read. Okay, hopefully you had the opportunity to read that. This comes from a research paper from Fazio and Ziegler from 2011, basically just reiterating that point that especially when it comes to solving fractions and those important number sense concepts, having that real world context can be really important. And so we'll go through today a few demo lessons that help students to build that real world context around fractions, ratios, percents, and then also some sort of proportional reasoning that's related to all of that throughout the middle grades. But we'll also kind of talk about ways that you can use Tuba in your own classroom so that students are generating their own data sets, making their own, so being able to create their own data to analyze and interpret, which can hopefully help them, aid them in this understanding of fractions, ratios, and percents. So it's a little bit about where we are going today. Okay. So I have 3 demos or 3 lessons that I'd love to explore with you all that kind of look at the progression of those skills, the part-whole relationship skills, as we move from 6th, 7th to 8th grade. Before I do that, I asked at the beginning for everyone to make sure you have at least a basic account for Tuba so that you can sign up for free on our website. If you don't have premium, that's totally fine. 2 out of the 3 lessons that I'll demo are free lessons on our website right now, so you can still access those even if you don't have a premium account. But if you could log into your Tuba account, that way you can kind of follow along with me as we go through these different demo lessons. So I'm going to pause for just a moment, let everyone go ahead and sign on using your account. If you haven't already signed up, you can do so by just logging in with your email. Okay, so hopefully everyone is logged in. I'm going to give just a quick tour of the dashboard for anyone who might be new to Tuba, and then we will jump into our demo lessons. So when you log in, you're going to see this dashboard, pretty kind of hopefully self-explanatory dashboard. That's what we hope anyway. But if you're curious about any of the pieces of your dashboard, you can always take a little tour. This tour will show you our content library, which we'll be looking at today together. It'll show you how to upload your own data, create a class, and it will point you in the direction of our support articles and our support tutorials, which can help you get started with using our tool. So if you're not familiar with our tool, our tutorials are a really good place to start with that. And you can find that by taking a tour or going up here to our PD. Okay, so we're gonna look at the content library to start, and then we'll come back and we will look at how students can upload their own data. So hang tight on that for now. We're gonna start with the content library. All right, so our content library is divided into math and science. We are obviously going to be looking at our math content library today. When you arrive on our content library, you're going to see our newest lessons arrive first. And we have just been recently putting out a bunch of new free data stories, which I'll talk about in just a moment. But those appear first because those are all new and newly released. But we're going to start by looking at a lesson in 6th grade math, where students are specifically looking at fractions and percentages, analyzing using a data set on dinosaurs. So here is our first demo lesson. It's called Analyzing Dinosaurs with Fractions and Percents. If you're unfamiliar with how our lessons look when you open them, every time you open a activity or a data story, you're going to see this teacher overview to begin, which will give you a preview of everything that students are going to be asked to do throughout the lesson. So we'll begin by a little overview of this lesson. Students are going to display and analyze data using dot plots and bar charts, understand the relationship between fractions and percents, and then convert between fractions and percents using benchmark numbers and double number line models. So that's what students will be doing throughout the activity. If you continue to scroll down, you'll see all of the instructions that students will get, each sort of step that they will take in order to complete this activity. You'll also see here at the top, if there are solutions available to this activity, they will always be here. So as you are going through as the student, or as trying it as a student, you will be able to see those solutions. You'll see a button that says solutions and you can preview those. Obviously on the student end, they will not be able to just see the answer. Those are only available because you've signed in as a teacher. And then over here, you have some information about the activity. So this is introductory activity, which means it's a little bit more guided. We also have activities that are summative, that provide a little bit less instruction, that require students to do more on their own. Although at the 6th grade level, they're still getting a good amount of directions because they are emerging in their data literacy skills and their skills in using the tool. Here we have our Common Core standards that this activity is aligned to. So this is our ratios and proportions strand within 6th grade math, a little bit about the mathematical content that they'll look at, the grade level, and then any other state standards that this might be aligned to. So for example, this is aligned to the 2nd number sense standard within the Virginia SOL. So this card is always available when you open up an activity. And if there are any other student handouts or teacher guides that we've created along with this activity, they'll also be featured here. So you're always welcome to kind of look at those. This will open as Google Drive, so you can make a copy and edit it, customize it to whatever you want to use with your students. Okay, so that's just a little preview of what it looks like when you open up an activity, but let's actually dive into this activity a little bit and see how students are using data to be able to practice their concepts of fractions and percents. So it'll always start with this teacher only, and then we'll dive into what the student view will look like. So if you see this yellow bar up here, that tells you that this is a student view. This is what students will be looking at. Okay, so let's begin by learning a little bit about this data set. So all of our data sets come with information about them. In the bottom left corner, you'll see an about icon, and this tells you and students what this data set is all about. So this data set is 29 dinosaurs and some of their attributes, like how big they were, what they ate, their physical features, their fossils, where their fossils were found. So that's a little bit about that. And this data set has multiple sources from where it was collected from. We also have some of the science strands that this is aligned to, the NGSS standards this is aligned to. So again, we're kind of using that cross-curricular understanding here as we are exploring fractions. Okay. So we're going to explore our relationship between fractions and percents using dinosaurs. We are not going to go through every step of this, but I do want to go through some of the pieces of this lesson to be able to show you the tools that are really helpful for students as they're looking at fractions, ratios, and percents, and some of the things that they'll get asked in order to apply their understanding of fractions. All right. So if you're unfamiliar with our tool, some things that are important to know, that all of the variables, which we call attributes of our data set, are displayed here on the left as in this, what we call the case card. So these are, if you were to look at this in a table view or in like a spreadsheet view, these are all of the columns of your spreadsheet. And we have visualized them all here as little attribute case cards. So here are all of the dinosaurs in our data set and all of their different attributes. Okay. And they have been mixed up here on our graphing window. So all of these are all of the cases mixed up. They're not in any particular order, but they are all linked. So if we were to click on this case 6 would appear here in our case card. It would also appear here highlighted in our table view. So case, I'm not going to be able to say that, euplocephalus, my best guess. at that dinosaur, and we can see all of the different attributes of that dinosaur. All right, so our directions here are telling us to go ahead and drag hip type to the x-axis, and we can see now our dinosaurs have been categorized into 2 hip types. And we are going to choose a bar chart of frequencies from our toolbar, and we are going to go ahead and count the totals. Please excuse my mouse. All right. So we want to know what is the total number of dinosaurs in this data set. Our case card will always tell us the total number of cases in our data set. And then we're asked what fraction of those are lizard, which is exactly half. So as you can see here, there are solutions to each of our questions. So you can preview all of those solutions before you assign this to your student. And I always tell people I recommend that you try this activity as a student before you assign it to your kids, just so you can see what they're going to be asked and plan your lesson around that. All right, so we have students calculate that fraction. Obviously, they didn't reduce that fraction. That wasn't one of their options. So that's something to keep in mind in terms of your instructional moves. But the reason for that is because they're going to then to be asked to look at this double number line and think about 4 out of 28 as a percent. So we're setting them up to be able to think about that in terms of this data set. Okay, so we go through sort of a little bit of instruction, reminding students of ways to simplify that fraction, and then how to calculate that as a percent. Okay. So we are going to take our geological period on our case card, and we want to isolate just one of the geological periods. So we're going to uncheck Cretaceous and Triassic. So we're just looking at the Jurassic period. And we are going to, again, put hip height on the x-axis. This time we want to know what fraction of dinosaurs have a bird hip type, which is 1/5. Again, we have that solution there, so we can see that before students are working on it. Okay, then students are asked to calculate the percent of 1/5. They have an option here. Then they have a free response question here where they're asked to calculate the remaining percent. And then again, once students have submitted that response, they get a little feedback from their double number line model so that they can see how that answer or how that response should have been answered. All right. The next few steps then have students sort of repeat that process, but rather than looking at hip type, now they're going to look at their diet. So they're going to look at the Jurassic dinosaurs with that within just the Jurassic dinosaurs, looking just at diet. They're going to calculate the fraction of dinosaurs that are carnivores, and then translate that into percent. So we're having them apply those skills that we just had them practice with the double number line. Again, they'll do that with number of legs used for walking. Okay, so they're getting multiple opportunities to practice that skill of calculating a fraction and then converting it into a percent. And then finally, they're asked to explain, what that procedure would actually look like if they were to replicate it again. Okay, so every activity ends with students being able to rate it and tell you what they think about it. And you can see that those responses on the back end of your dashboard, which we will talk about in just a moment, if anyone is interested in seeing how you can see student responses as they're completing an activity. All right. So this is obviously a 6th grade lesson. So in 6th grade, students are, um, working on calculating fractions, understanding the operations that go into um, finding a fraction to begin with, and then also taking that fraction and converting it into a percent. They also begin to have, they also learn about what a ratio is and start to use ratios. And then in 7th grade, they take their understanding of ratios and then they start to apply that to proportional reasoning. So I wanted to look at how students then take the skills that they've begun in 6th grade and start to use that in their understanding of ratios in 7th grade. So we're going to look at a 7th grade lesson now. This one is premium, so if you do not have a premium account, you can just follow along with my screen. If you do have a premium account, you can kind of play along with it as we go along. This one is called Investigating the Ratio of Arm Spans and Heights with Dot Plots. So in this activity, students are going to be able to use ratios to make comparisons. They're going to interpret the meaning of those ratios using data, and they're going to apply their understanding of ratios in context of data analysis. Again, this is 7th grade. The standard is over here, again, in that ratios and proportions strand. And also this activity in particular is aligned to one of our illustrative math lessons. So before we leave, I'll also show you if any of you are users of illustrative math for your core curriculum. We do have some collections that where we've aligned IM lessons and units to Tuba lessons so that you can kind of use that as either a direct replacement of an IM lesson or a direct extension of an IM lesson if you do use that curriculum. So I'll be sure to show you where those are located before we head out. All right, so let's go ahead and look at this data set and play around with this a little bit, see what students are going to be asked to do in this lesson. Again, I always love to start by pointing people to the about in the bottom left so that we can see where these data come from, so that we are always encouraging students to make that connection that this is not just some random number on your screen. It's not an ordered pair. This is a piece of data that has been collected about a person, place, or thing. So all of these cases are from something, right? Some data that's been collected. So these data come from the Bay Area Science Fair, which is a 10-day festival held primarily to engage young people in fun and excitement, awe of science, and creativity. So these data were collected around participants who were visitors who were there, and they're about proportions of the human body. So we took measurements of a bunch of people, 300 people, because there are 300 cases here, took 5 different attributes, and so that's where we got our data set from. This comes from Bay Area Science. All right. So here again, we have all of our cases mixed up in our graphing area. Here are our 5 attributes this time: name, age, sex, height, and arm span. So students are introduced to the activity with a little bit of context around why we were taking these different measurements. So Marcus Vitruvius observed that among other relationships, a person's height and their arm span are approximately equal. Leonardo da Vinci also drew the famous Vitruvian Man based on this observation. So probably something that students have at least seen before. They've probably seen that picture from Da Vinci. If they haven't, that'd be a great way to kind of activate them at the beginning of the lesson with some kind of engagement around that. So what do you think? First, our hypothesis, what do you think the data will show about the relationship between height and arm span? From our preview, we know that they're probably going to be about equal. What do you suppose is the typical ratio of height and arm span of a person? So we would expect probably close to 1 because we said that they're going to be about equal. So students will make a solution there. And whenever we have solutions that are available in an activity that is kind of open-ended, we try to give you some kind of sample answer that students might have or that we might want them to have based on that open-ended question. But obviously they're all going to vary just based on students' understanding going into the lesson. Students will say all kinds of things, as you know. All right. So we are first looking at our very first case, which is a student named Waylon. If we didn't see that, like if that didn't pop up as case number 1, let's say we had clicked on something here, we can always go into an attribute and filter by whatever it is that we're looking for. So we're looking at just this student right here, Waylon. They are our first student, or our first observation here in our data set. They're 14 years old, and they are 71 inches tall. Okay, so we want to use a ratio to describe the relationship between Waylon's arm span and his height. So arm span to height is going to be 68 to 71. So we can see our relationship here. It's pretty close to 1, as we might have predicted. Okay, so students are investigating with that. Okay, it will always give them, for questions like this where we've sort of asked, we will almost always have some kind of feedback here to help students understand that calculation. So again, we have that feedback. And then this is, one of the core parts of this standard is having students be able to calculate or use a ratio table in order to create ratios. So here we have a little ratio table that students are asked to fill out. And from that ratio table, we want them to pick out which student has a ratio of 1 and who has the lowest arm span to height ratio. So we can see our solutions there. Okay, and again, they're asked to do some more questions. Let's see if we can get some directions. So they're going to be asked to look at our data. They're going to filter out some people, look at some specific students, and determine their ratio, the ratios of their arm span to heights for various cases within this data set. Okay. So they'll repeat this procedure multiple times, giving them multiple opportunities to practice this skill, feedback as they go. Obviously, the solutions are there for teachers, but not for students. So they will only see this feedback after they've responded. Okay. So they have some more sort of free response questions towards the end. And then at the end of this lesson, we have a little opportunity for you as the teacher to pause and have the students actually investigate this in a group. They've been given some more open-ended questions, some investigation prompts so that they can go in and kind of choose who they're going to investigate, which students they're going to look at, and then answer some more open-ended questions at the end. So this one, as with many of our activities, so our 6th grade activity that we just looked at was a little bit more cut and dry in terms of students were asked to, answer a question and respond with, an exact percentage or an exact fraction. So more calculation based. Many of our activities, and in particular our data stories, which I'm going to demo next, are really focusing on that conceptual understanding, having students also practice that skill of mathematical argumentation and mathematical writing. So that's something that we believe is a really important part of building data literacy, is being able to explain and tell a story based on what the data is telling us. So this activity, and then the one we're also going to look at for 8th grade students with continuing on with these skills, really have students practice that mathematical writing. So if you'd like to explore this in more depth, you can continue to do that. I am going to demo one more thing for us from one of our recently released data stories. So we have started putting out data stories once a week, and they follow 5 instructional strategies You can see sort of brief discussions about the purpose of each of the instructional strategies here. But data stories are really great, very short lessons that you can use in a number of different ways in your classroom. But the goal is really to focus on building data literacy skills, less on trying to achieve specific grade level standards. So our goal with these is really to get students thinking and asking questions about data, recognizing patterns in data, and getting to that mathematical writing piece, being able to, like in the one that we're going to view in just a moment, make some observations and make some questions about data in a very sort of open-ended way. So these strategies are, we did not invent these strategies. These come from research best practices in math. And again, with kind of the goal of building that mathematical argumentation. All right. So this data story, which we actually just released last week, is about New York City's squirrels. And sounds kind of random, but there is a organization called the Squirrel Census that gets volunteers to go out into New York City's parks and make all of these observations about what squirrels are up to. And they call it the Squirrel Census. So these data come from the Squirrel Census. Again, this is a data story, so this is going to look a little different from the activities that we just looked at. It's much quicker, can be used in about 10 to 15 minutes in the classroom, sort of like as a do now. So in this data story, students are going to look at, they're going to look at two-way tables, but they also have the opportunity to discuss fractions, ratios, and percents, because we'll see in just a moment that they can, they'll be able to kind of pull out that content if, sort of asked to do so. All right, so let's go ahead and take a look at this data story. All right, these data come from 433 squirrels that were observed across New York City parks. They were observed doing many things like eating, running, chasing, climbing, etc. All right, so our data stories will generally start with kind of an introduction to the data set, so students can start to kind of just look at a visualization or play around with the data just a little bit in order to get them acquainted with the data set before they actually dive into whatever instructional strategy is being used for that data story. This is a notice and wonder, so they're going to make some observations and ask some questions. But first, they need to actually look at this graph state and decide which of our parks had the most squirrel observations. So where were the most squirrels observed? That was at Thompson Square Park. If they wanted to, they can play around with this, with the data a little bit more, but here are all of the different attributes that were collected about our New York City squirrels. Oh. My computer is being just a little bit slow, so we'll give it a second to load. All right. Okay, so they are then given this two-way table, which they can use as a two-way table, or they can use as a way of making observations about fractions or percents. They can also play around with our percent tool up here, our percent in our count tool on our toolbar. They can look at the percents. You can manipulate the percents by column and row, okay? But the goal of this data story is just to get students asking questions and making notices about the graph to the left. So on our x-axis, we have foraging. On our y-axis, we have eating. And our graph has been colored by whether or not the squirrel approaches humans. So in this category, these are squirrels that were not foraging, not eating, and in pink, they were not approaching humans, but in green, they were approaching humans. So we have this really interesting opportunity to be able to make some notices and wonders about our squirrels in terms of what we see with this data. With our data stories, I will say that they are very open-ended, which means that as a teacher, you have the ability to give more or less directions based on what you want your students to be able to make observations about within this data story. So that means that if you want them to specifically mention fractions, percent, ratio in your answer, you can provide them with those directions, but we keep them really open-ended so that kind of students can do with it what they will. So they're going to get the same graph state again and make some wonderings about this. And one of the things I love about data stories is that, with these types of sort of activation strategies, is that when you first start to assign them, when I would first do things like this in my classroom, my students' answers were really kind of basic. And as they continue to engage in activities like this, and improve their skills and argumentation and things like that, their answers become more complex. So it was really great to see that growth for activities like notice and wonder and the other instructional strategies that we use here. Okay, so this is three quick steps. They're presented with this visualization. They have to make some notices and wonders. We do give them the prompt here to use academic vocabulary and complete sentences. So that's something we always encourage. And then that's it. Students are done and can rate this data story and say what they think about it. So again, just a really quick sort of way for students to get those data literacy skills in kind of bite-sized pieces. Okay, I don't see any questions in the chat. So I did promise you all that I would show you a couple of things that you can use with your students in addition to what we already have here in terms of fractions, ratios, and percents. So I'm going to go to our upload data set feature and just show you how students are able to enter their own data, or how you can enter your own data set if you have a data set you want students to look at, or if you all as a class collect your own data and want to put it into the tool. So from this upload data set icon at the top of your dashboard, you can insert data. And when you insert data, it's going to pull up our table view down here at the bottom. And you can directly enter data into our table view, just like you would into like a spreadsheet in Excel or something like that. The difference is that when you enter data into here, like let's say I'm going to do cat. Okay. So as you start to enter your data into our tool, it automatically logs your data. First of all, it recognizes your attributes, whether it is categorical or numerical, and then it will begin to plot your data up here on the graph state. And then once you save that data, you can save some information about that data set for yourself. This is always going to stay private to you unless you change the settings so that you can share it with your students. But you can give that data set a name. You can give it a source if you've gotten it from somewhere else and the source URL. You can add a description if you'd like about where these data come from. Okay, but you can do this, and students can also do this with their free account, with their basic account. So you can have students kind of collecting data, whether that's from something you're doing within the math classroom or something they're doing within the science classroom. They get to really be real active participants in that data collection process. So that's one way you continue to use data in your classroom, even if you don't see something here that directly aligns with what you're going to teach, or you have other content that you want to use data for that maybe we haven't developed a lesson for. You can create your own data set. You can upload your own data set as well. We have all these options here. You can also look at our data set library. So we are constantly uploading this data set library. We have almost 400 data sets here. that are arranged in a number of different ways. And even if you are coming to us on a basic account, on a free account, we have 28 data sets that are available here for free that you and your students are able to use. And we are constantly changing out which of these data sets are free when we feature different activities and things on our website. So do check these out. We have also just launched a create activity feature. So if you see a data set that sounds really interesting to you, but we haven't created an activity around it yet, you have the ability now to create your own activity. This was for anyone who's interested in the New York Times. This is a data set that we just recently updated. The word of the day, let's say you wanted to do something involving fractions related to this data set, you could create your own activity. This create activity feature is going to have you go through all the steps that we use to create activities as content specialists. It'll give you some prompts here for what is required. And then you can save and publish your data set to your for your students to view. If you do create an activity, that activity is going to be private to you, and then you can share it and assign it with your students only. So students have to be registered into your class in order to be able to use that activity that you've created. It will not be available for other teachers on our website, just because we can't vet everything that people are going to make, and so that will just stay private to you as you create that. All right, so that is a bit more about how you can upload your own data and then find data sets on our data set library. Just wanted to show you one last thing before we close out, which is our collections. So for those of you who are using Illustrative Math or have, excuse me, looked at Illustrative Math in the past, we have done work with them to align our lessons to Illustrative Math units and lesson plans. So you can see here, all of our middle grades have been aligned to Illustrative Math content. So when you open one of these collections, what we've done is we've tried to just put all of the lessons that we have that are aligned to these different units and lessons in a really consolidated place so that they're easy to find. Our goal really is that, you know, we aren't trying to replace a core curriculum. What we want is to be able to enhance and supplement a curriculum in order to bring that real world context into the classroom. And so we're trying to make that as seamless as possible for our teachers. So IM has been an easy one to do that with, since they have all this open source curriculum. But if you have a curriculum that you use and you're looking for ways that you want to align Tuba lessons with your curriculum, I would love to talk more about that. So I'll share my email in the chat again before we head out. But you can see here, so we have all of our units, and then within each unit, we link to the IM lesson and then provide some recommendations for, you know, if you're working on lesson 4 in unit 6 and you want some ways that you can use real world data in order to supplement that lesson or in order to replace that lesson, then, you know, or to replace parts of that lesson, then here are the recommendations that we have for you. So this is a really great resource. I also think that because IM is aligned to the Common Core, even if you don't use IM, likely you teach many units that look very similar or many lessons that look very similar. So if you are in the middle, like teaching in the middle grades for math, then I would take a look at our collections for Illustrative Math 6th, 7th, and 8th, just because I think they give some really good ideas of where Tuba can fit into the Common Core standards for each of those grade levels. We also do have Algebra 1 and Algebra 2. So you can take a look at those as well to kind of see the progression. We have science ones too, but obviously we're not a science group, so I won't go into those. All right. That is all I have for us today. As promised, I do want to leave you with my email, so I will go ahead and drop that in the chat. If you have truly any questions about tuba for math, if you want some ideas of how you can incorporate this into your classroom, I would love to chat with you. Please feel free to send me an email, and I will absolutely get back to you so that you can find ways to be using this in your classroom with your students. I am a big believer that math can really be enhanced, especially for our Gen Z students, with real world applications, so that students are really able to make those meaningful connections between their math instruction and the real world. So really happy to chat with you if you have any questions. I will hang out for a couple more minutes, just if anyone has any questions to ask and you'd like to leave those in the chat, I'm more than happy to answer those. And if not, then thank you so much for being here. Have a wonderful rest of your afternoon.